So, what is data? Data is the foundation of modern decision making. It's all around us, waiting to be collected, organized, and transformed into meaningful insights. And this is a technical definition of data. Data refers to collection of raw, unorganized facts, figures, or piece of information. In data analytics, data represents the values or observations of variables. So, what do we do with data? We fetch the data in the raw form, and then we process it, and then we extract some insights out of it, and then we make decisions, and that's our final product. Let's look at an example. Imagine you own a small coffee shop. Throughout the day, you record every sale: 9 a.m., 9:03, 9:05, 9:06, so on and so forth. So each line is a raw piece of data. By itself, it doesn't tell you anything. But if you collect it for the month, you can understand the patterns and draw some meaningful insights. So, in this situation, the insight would be lattes are the best selling item and we are busiest between 8 a.m. to 10 a.m., so on and so forth. So, there are two families of data: one is qualitative data, and the other is quantitative data. Qualitative data describes qualities or characters like favorite colors, product categories, customer feedback, t shirt sizes, etc. You count and categorize this type of data. Whereas quantitative data, it represents numbers. You can perform mathematical operations on it, like sales revenue, customer count, temperature readings, product weights. You calculate and measure this type of data. So let's look into qualitative data. Under qualitative data, we have nominal data and ordinal data. So in nominal data, it talks about uh, uh, frequencies only. There is, let's say, you have under red three responses, under blue two responses, under green one response, let's say, and this is for your favorite color survey. All right. Now you can't actually say this is the average color, right? You can only count the frequencies. It's like you do not have any ranking system here. Like red isn't any better than blue, or blue isn't any better than red. Whereas in ordinal data, it has a logical order, like t-shirt sizes: small, medium, large. You know, large is greater than small, medium is greater than small. This will give us meaningful ranking information. Now, coming to quantitative data, we have discrete data and continuous data. Under discrete data, uh, we can actually say, let us say, you say average, on average, you have 11 customers per hour. Okay. Now, you can either have 10 customers or 11 customers. You can't have 10.5 customers, right? Other examples would be cars in parking lot, number of sales, shoe sizes, etc. But whereas continuous data, it is measured within a range, right? Let's say the temperature is between 21.5 and 25.8, let's say. Between 25.1 and 25.8, there are so many numbers, so many values that are possible. Other examples would be height, weight, time, distance, so on and so forth. Now, what is the difference between structured data and unstructured data? Now, unstructured data, I will give you an example. Okay, a customer emails and she says, "Hi, I love the latte I bought yesterday, but the muffin was a bit dry," which is a very valuable data, and it's the fact for that instant. But analysts usually hate this kind of information because they cannot process it, just like computers cannot process it. Whereas structured data, let's say the customer has given their information in a table which contains name, date, item rating, etc., as their column names, right? Now this data looks much clean, the rows are organized, columns are organized, and computer can easily analyze, read, sort this kind of data. So data analysts usually prefer this format. Now we'll talk about a historic case study. In 1854, there was a cholera outbreak. All right. And that was in London, and it took over 500 people in just 10 days. And people thought they died because of the bad air, and this is just a theory. Now, there was one doctor called as John Snow who went door to door recording the addresses, names, time of death, place of death, and so on and so forth. He collected all the data. Now, he structured the data by opening a map and plotting the deaths. Now, he understood one thing, that deaths are clustered densely around the street called as Broad Street Pump. Right? A nearby prison also had few deaths because they have their well, then they have their own well, and a brewery had zero deaths because workers drank beer and not water. All right. From this insight, uh, Snow convinced authorities to remove the pump handle. The outbreak stopped immediately, and cholera was in water, not in the air. And this is how data analytics save lives. So let's look at the key takeaways. So we have learned that data is the raw material, and we need to understand our data and then structure, which will further reveal insights, and then that will drive us to decision making. So this is our journey from data to decision making.